welcome to AQA A-Level Physics, Particles and Radiation, Constitutes of the Atom. We should be familiar with the model of the atom from GCSEs. This is the positive protons and neutral neutrons inside the centre of the atom in a nucleus, and the electrons orbiting far away inside of energy levels. I'm going to point to highlight the distance between the nucleus and the electrons here. If this clock was the size of the centre of the nucleus, then the electrons will be orbiting about 20 kilometres in each direction. That's the scale of the complete space within the atom. We should also be familiar with this sort of table. Protons, neutrons and electrons with mass and charge. Mass is 0.005 plus 1, 0, minus 1. Now, the thing to notice about this is that this is relative mass and this is relative charge. It's relative to other particles. It's not actually in kilograms or in coulombs. This atomic mass unit, these are measured in atomic mass units. Now we can write it in traditional mass in kilograms, charge in coulombs with our SI units. Protons, neutrons and electrons in terms of mass. Protons have 1.67 times 10 to the minus 24 kilograms of mass. Whoops, actually made a mistake. Minus 27. And these are 9.11 times 10 to the minus 31. This is all in kilograms. And we can notice that this is 4 orders of magnitude down in about 2000, hence the 1 divided by 2000 mass of the electron. This here is the value of 1 atomic mass unit, hence the approximate 1 and 0.005. In terms of charge in coulombs, proton is plus 1.6 times 10 to the minus 19, electrons are minus 1.6 times 10 to the minus 19, and of course neutrons are neutral. These are the numbers you will have to learn of the values. You also have to be familiar, and you should be from GCSE, with AX, Z sort of notation, with X being the element symbol, Z being the proton number, or the atomic number, and A being the atomic mass, or what is sometimes called the nucleon number, the mass of the nucleus. That's a bit scrunched against the side. You should be familiar with that from GCSE. The last thing in this part is isotopes. Now, this is a beryllium. There's 4 protons, which means that this is beryllium. Looks like that. There's 4 protons and 7 minus 4, 3 neutrons. But notice how there's 4 neutrons here. That's because it's an isotope. Isotopes have more or less or just different amount of neutrons than what is found on the periodic table. This can be written in the AXZ notation, like this. But because these two are the same, if this changes, this changes. So you can always find one out from the other. We can disregard one of these and refer to this nucleus as beryllium-8, because beryllium always has 4 protons and 8's its mass number. So if you hear things like carbon-14, that's carbon with 14 protons and neutrons inside. And as that is the symbol, we can work out that 14 minus 6 is 8. It has 8 neutrons inside. That's all for today's video. Hope you learned something. Goodbye.